Good morning, students. Welcome back to the online computer class. Students, this video is a continuation of our first chapter, number system. Let's see what we have studied in part 1 in the previous session. Students, in part 1 of number system, we read about what is number system and what is base. What is the need of number system? Types of number system, that is decimal number system, binary number system, octal number system and hexadecimal number system. We learned the base of these number system and the digits consists with in it. Conversion of decimal number system into binary number system and conversion of binary number into decimal number system. I hope you must have understood the base. Now, I would like to discuss the answers of your homework given in your previous session. First question was, name the types of number systems. Answer is, there are 4 types of number system. They are decimal number system, binary number system, octal number system and hexadecimal number system. Now, the second question. Now, the second question was to convert the given numbers into binary numbers. The first number was 68. According to the rule of conversion, we will divide 68 by 2 and will write the quotient and remainder. So, when we will divide 68 by 2, 34 is quotient and 0 is remainder. Again, we will divide it by 2. Now, the quotient is 17 and remainder is 0. We will divide 17 by 2 again. Now quotient is 8 and remainder is 1. Remember students, we have to repeat this process until we get 0 in quotient. So we will divide 8 again by 2, then the quotient will be 4 and remainder will be 0. Again we will divide 4 by 2, then quotient will be 2 and remainder will be 0. Again dividing it by 2, we will get quotient 1 and remainder 0. Again dividing it by 2, we will get quotient 0 and remainder 1. Now the quotient is 0, so we will stop the division process now. And write the remainders in reverse order, means the last remainder is 1. We will write it in first as 1, then 0, then 0, then 0, then 1, then again 0 and 0. So 68 in decimal will be written as 1 0 0 0 1 0 0 to the base 2 in binary. The second number was 987. Again we will start by dividing 987 by 2. So 493 and will be the quotient and remainder will be 1. Now divide 493 by 2. 246 is quotient and remainder is 1. Divide 246 by 2. 123 is quotient and remainder is 0. Divide 123 by 2. 61 is quotient and remainder is 1. Divide 61 by 2. 30 is quotient and remainder is 1. Again dividing it by 30, 15 is quotient and remainder is 0. Dividing 15 by 2, quotient is 7 and remainder is 1. Again dividing 7 by 2, quotient is 3 and remainder is 1. Dividing 3 by 2, quotient is 1, remainder is 1. Again dividing 1 by 2, quotient is 0, remainder is 1. Now writing the remainder in reverse order, we will get 1 1 1 1 0 1 1 0 1 1. So the value of 987 to the base 10 in decimal is equivalent to 1 1 1 1 0 1 1 0 1 1 in binary.
Now students, the second question was to convert the binary number into decimal number. The first binary number 1 was 1011 to the base 2. Now to convert this into decimal number, we will multiply each binary number with its positional value. Now multiply 1 with 2 to the power 3. Since 2 is the base of binary number, so we are taking 2 here. Now multiply 0 with 2 to the power 2, 1 with 2 to the power 1 and 1 with 2 to the power 0. Now according to the rule, add all these. We will get 1 into 8 plus 0 into 4 plus 1 into 2 plus 1 into 1. We will get 8 plus 0 plus 2 plus 1. Adding this, we will get 11. So binary number 1011 is equivalent to 11 in decimal number. The second one was 100110. Similarly, we will solve this. We will get 1 into 2 to the power 5 plus 0 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. We will get 32 plus 0 plus 0 plus 4 plus 2 plus 0. Adding this, we will get 38 as answer. So binary number 100110 is equivalent to 38 in decimal.
Students, now let's start today's session. The topics which I am going to cover in today's session are octal number system, hexadecimal number system, binary arithmetic. We will read about the introduction of binary arithmetic only in this session. Students, we will start today with third type of number system, that is octal number system. Octal number system. It consists of 8 digits, that is 0 to 7, and its base is 8. The concept of octal number system came from the Native Americans, as they used to count numbers by using the space between the fingers rather than using their fingers. Now we will learn the rule to convert octal number into decimal number. The conversion process of octal number to decimal number is similar to binary to decimal conversion. The only difference is change of base. Now we will read about the rules. Multiply each octal number with its positional value, which is in the terms of powers of 8, starting from the extreme right digit. Increase the power one by one, keeping the base fixed as 8. Sum up all the products to get the decimal number. Now let's see an example for converting octal number into decimal number. We have taken a number 345 to the base 8 and we have to convert this number into decimal number. Here 3 is multiplied with 8 to the power 2 since the positional value of 3 is in hundreds. 4 is multiplied to 8 to the power 1 and 5 is multiplied to 8 to the power 0. Adding the products, we will get 192 plus 32 plus 5, which is 229. So 345 to the base 8 in octal number is equivalent to 229 in decimal. Students, now we will read about hexadecimal number system. This number system consists of 16 digits 0 to 9 and the letters A to F, where A to F represents digits 10 to 15 and the base of hexadecimal number system is 16. This number system is also known as hex, where hex means 6 and decimal means 10. So it is called hexadecimal number system. Now for converting hexadecimal number to decimal number, we again have a rule, and that rule is same as binary to decimal and octal to decimal conversion. Let's see the rules now. Multiply each hexadecimal number with its positional value, which is in terms of power of 16. Increase the power one by one, keeping the base fixed as 16. Sum up all the products to get the decimal number. Now, look at the hexadecimal to decimal number conversion table, where 0 in hexadecimal is equal to 0 in decimal, 1 in hexadecimal is equal to 1 in decimal, 2 in hexadecimal is equal to 2 in decimal, 3 in hexadecimal is equal to 3 in decimal, 4 in hexadecimal is equal to 4 in decimal, 5 in hexadecimal is equal to 5 in decimal, 6 in hexadecimal is equal to 6 in decimal, 7 in hexadecimal is equal to 7 in decimal, 8 in hexadecimal is equal to 8 in decimal, 9 in hexadecimal is equal to 9 in decimal, A in hexadecimal is equal to 10 in decimal, 11 in B in hexadecimal is equal to 11 in decimal, C in hexadecimal is equal to 12 in decimal, D in hexadecimal is equal to 13 in decimal, E in hexadecimal is equal to 14 in decimal, and F in hexadecimal is equal to F in decimal. That is how we will use the conversion. That is how we will use this table by conversion. Now, to understand the procedure of conversion more clearly, let's see the example. The number which we have taken here, for example, is 3b to the base 16. We will start with multiplying 3 with its positional value, which is 16 to the power 1. Again, the value of b is 11, which we know from the previous conversion table. Now multiply 11 with 16 to the power 0. Now, completing the procedure, we will get 48 plus 11, which is equal to 59. So 3b in hexadecimal is equal to 59 in decimal number system. Now we have to learn about binary arithmetic. Binary arithmetic. Well, this term arithmetic is that which involves the addition, subtraction, multiplication and division of binary numbers. In mathematics also, you might have learned arithmetic, in which you would have learned addition, subtraction, multiplication and division with decimal numbers. Now, we have to do the same thing with the binary number. Fine. As you know, students, that our computer work only with binary data, and this binary data is in the form of zeros and ones. Okay, so when we give any task to our computer has to perform that task using 4 basic functions, and these 4 basic functions are addition, subtraction, multiplication and division. It means for every task our computer has to add, subtract, multiply and divide the binary form of data. Okay, let's suppose you are writing a word, so that means you are giving instructions to our computer, and all these instructions will be converted into binary number, and then these instructions will be performed by binary arithmetic. So that's why it is important for us to learn binary arithmetic. Now let's read and understand computer. Computer processes the data after converting it into binary equivalent. The processing of data is carried with the help of various arithmetic operations on the binary numbers like addition, subtraction, multiplication and division on the decimal number. Now, this was about what is binary arithmetic. I will discuss binary addition, subtraction, division and multiplication in my next session. I am ending today's session with some homework for you all. So for your homework, the first question is convert 321 to the base 8 and 152 to the base 8 into decimal number. That means to the base 8 means these numbers are in octal number system and you have to convert it into decimal number. Second, convert 1 2a to the base 16 and 30b to the base 16 into decimal number. Since the base is 16 here, so it is hexadecimal number. Okay, you have to convert these two octal number into decimal number and two hexadecimal number into decimal number. I hope submit your homework till Wednesday 5 p.m. at my email ID given in your welcome note. I hope you all would listen the video carefully. Thank you.